Okay, this is the second video in the Unit 1A test review. Let's just go ahead and get started. We have number 11. If the limit as x negative infinity for f of x equals infinity, and the other way, as x approaches infinity, my function approaches negative infinity, and we have this function here. So whatever this coefficient is, so I've got my coefficient here of a, and then I've got some kind of exponent here. It wants to know what can we know about the values a and b. Well, with any kind of in behavior right here, this is in behavior, because this limit notation and the fact that my function's approaching infinity and negative infinity, because I have it both ways, right? As my x goes to the left, as x goes to the right, that's telling me that this is in behavior, okay? I like to draw these out, so I'm not gonna be the best graph ever, but let's go with the first one here. So as x approaches negative infinity right here, x approaches negative infinity, what that's telling me is that as x goes to the left, because negative infinity is to the left, my function goes towards infinity. So as I go left, my function goes up. And the opposite here in yellow. As x goes to infinity, my function goes down. And it doesn't really matter what I have here. I can literally draw a line like this. Like, you're not going to see a function like that. It'll look more like this. But what I mean by that is I don't really need to know what the function looks like between it. I can just tell that because my function goes different ways, that it's odd degree. So odd degree ends opposite, then even degree ends equal. That's just a kind of a shorthand way to remember that, because highlighted in pink here, these guys are going opposite, and that's exactly what an odd degree does. So that tells me here it's odd degree. Degree is talking about exponents, so I know b is odd. Okay, and for odd degree functions down here in red, for positive, like for a leading coefficient that is positive, so if a is positive, I look like this. And then if a is negative, I look like this. Okay. And here, this one matches that a is negative, so I know here my leading coefficient is going to be negative. A is negative. And this is always talking about our rules for our coefficients and degrees. And here's a helpful chart if you want to use that to remember it. So if I break it up into pieces, so here, if I have odd degree, even degree, and then positive leading coefficient, and then a negative leading coefficient. So odd degree is as x approaches infinity, f of x does the same thing. And as x approaches negative infinity, f of x does the same thing. And then for a negative leading coefficient, these just flip. So as x approaches infinity, f of x flips to negative infinity, and as x approaches negative infinity, f of x approaches infinity. Okay, and then for even degree, we kind of already talked about it. Even degree ends equal, so my end behavior does the same thing. So I'm either going to have both go to negative infinity or both go to positive infinity. So for even degree and positive, I have as x goes to infinity, my graph goes to infinity, my my y values do as well. As x goes to negative infinity, my function values go to negative infinity. Okay, same thing here. Boom. As x goes to infinity, f of x goes to negative infinity, and as x goes to negative infinity, f of x goes to negative infinity as well. Okay, so both of these here in pink are negatives. Now, right here, it wants the point of inflection, interval of concave up, concave down, interval of increase, interval of decrease. So let's just write these out. Like, I'm just going to write them down and point to them. So point of inflection, what do I need to know first? Well, it's going to be halfway between a max and min. So point of inflection is always halfway between a max and min, between two extrema, like approximately at least. So this is 2, 1, and this is 3, 0. So if I 2 plus 3, add the x values and divide them by 2, and I add the y values and divide them by 2, I'm going to have 5 over 2, which is 2.5, and 1 plus 0, which is 0.5 when it's divided by 2. So my point of inflection is at 2.5, 0.5. Remember, you always need to find the point of inflection first. So 2.5, 0.5. Because that helps me do interval of concavity. So you read a function, you read a graph just like you read a book, go from left to right. So the first thing I do is I'm going to trace it here to make it seem easier. So boom, concave down like a frown, okay, until my inflection point. Just drew it a little bit too far, so about right there. Okay, my inflection point is approximately right here. That red dot, I'll change it to yellow. So the yellow dot there is about where I switch. So I'm concave down like a frown first. So intervals of concave down, I'm just going to write here that it is, make this a little skinnier. So my intervals of concave down are from negative infinity to 2.5. And then I'm going to be concave up in green here from my point of inflection. And then I don't switch back, so I'm concave up from 2.5 to infinity. And then increasing and decreasing is just talking about whether my function is going up, rising, or going down. So if I look at this you go left to right once again. So I go green until 2. So at 2, I switch back to switch to decreasing. So interval of increase first, so from negative infinity to 2. And then from 2 to 3 right here, colored in yellow, from 2 to 3 I'm decreasing. So interval of decrease, 2 to 3. And then from 3 to infinity, highlighted in pink, from 3 to infinity, I am going up. My function's going up. The arrow's going up forever. So from 3 to infinity, I am an interval of increase. So U, just my little union sign, 3 to infinity. Okay. Name the global extrema present and give the global extrema's coordinates using the function below. So all you would do is type this into your graph. So this is an even degree function. So I know with even degree, always has, switch colors, always has a global max or min. So I'll even agree, always has a global max or min. You would type it into y equals. So you would use your calculator. Type it into y equals. You would graph it. So these are calculator buttons. You would graph it. You would you might need to zoom in or out, so you can just press zoom, then zoom in, zoom out as you need to. And then once you figure out if it's a max or min, you would go second trace, and then either choose max or min and find that. So I'm going to do all of those steps really quick. Negative x to the 8 plus 2.7 x to the third. Graph it. Calculator's not a fan of it. Okay, and then I can see that this has a global max. Second trace, find this maximum here. Ooh. Second trace, maximum. Go to the left bound. Go to the right, guess. Okay, and remember, when in doubt, we do not have, like, it doesn't tell me what to round to, so we always round to 3 decimal places in this class. So my global max, if I round it 3 decimal places, is 1.002 and 1.700. And really, you could round that to, just write that as 1.7 if you wanted to, but 1.002 to 1.700. Now here, it says let f of x, or let f be equal to f of x, and then it gives my function. It wants the zeros and multiplicities. So zeros and multiplicities. So you set these equal to 0 and solve. So 7x minus 4 equals 0. That gives me 7x equals 4, x equals 4/7. So that gives, and here my multiplicity is 8. So my 0 is 4/7 with a multiplicity of 8. The next portion here, just do this for all your zeros. So x minus 100, x equals 100. Just add 100 to both sides, and then it has a multiplicity of 2 because of the exponent. And then 10x minus 8 equals 0, 10x equals 8, and then I do 8 divided by 10, which is going to be 4/5, or you could put 0.8, either way. Multiplicity, and all of this is going to be multiple choice, so you don't have to worry about is it a fraction or is it a decimal. And then this here is 3. And then my last one, x plus 6 equals 0. So that gives me x equals -6. There's no, like this arrow up here, there's no number written, so we just know the exponent is 1, therefore the multiplicity is 1. Okay? It says, what are the coordinates of the approximate inflection point of the function? So here, what we have to do to have an inflection point, so we've already said like a point of inflection is approximately halfway between a max and min. Okay, so what I need to do in order is find So I need to find the max and min with my calculator, and then just find the midpoint of those. So for step 1, my max So finding the max and mins really quick. I'm doing like I'm working through this just at the same pace like you all would. Like I'm just doing the same things you all are doing, same things I'm asking you to do. I'm doing it myself. So going to the left, going to the right. That max is at 1, 2. My min is at 3, -2. So my midpoint is going to be at 1 plus 3 over 2, comma 2 plus -2 over 2, which is going to be equal to 4 over 2, which is 2, 0. So the coordinates of my approximate inflection point, if I can click this, the approximate inflection point here is going to be at 2, 0, approximately halfway between my max and min.